I'm here today to share with you a little bit about what's happening in lighting. Obviously, I'm only going to touch on a small part of it. We only have an hour, and we probably have less than that now. But so it's a very big subject. I'm going to try to hit what I think is important, and also a little bit about what we're doing at UCF, that hopefully you can take away some of that and use it in your facilities. So this is a series one in a series of 4 workshops. And this is the 3rd one, and we've covered introduction to energy management, we've covered HVAC, this is lighting, and the last one is about everything else remaining, like the plug loads and the office equipment, that we might be able to come up with ways to control that. This is a couple of quotes that I found on the web that relate to the subject. DOE Energy Star program that Christina was just talking about estimates that 26% of the energy we're taking into our commercial buildings can be eliminated through conservation means. The other one I thought that was interesting is this from the building commissioning people. They estimate that only about 5% of our commercial buildings are being commissioned, and that's something that we're going to talk a little bit about today. People think about HVAC systems being commissioned, but I think that the new lighting technology, the new controls out there that are on lighting, need to be commissioned as well. Talk about how important I think that is. It's a little overview of the process that we use, and it's also the process that's presented in Energy Star's Portfolio Manager program. We talked before about how important it is to make a commitment from the organization, that this needs to be at the very top level of the administration. And in our case, it's the president making a stance and saying that we're going to do this, and that I believe in it, and I'm behind it, kind of thing. The next step would be to assess performance, and we talked a lot about that on the first workshop, the baselining techniques that we use, and in this CFEEA program, we're really looking for you to use the Energy Star Portfolio Manager, which is a great tool, free tool that Christina talked about, although it's a little cumbersome sometimes to work with, but it's not bad after you get into it. Next step would be to set goals, to what you really want to achieve, kind of thing. And CFEEA has some goals out there that they're recommending that we work toward. And then really the meat of this whole thing is this create and implement a plan. And what we're talking about here is primarily the demand side management. And we break those loads up. Typically they're broke up into 3 categories: HVAC, lighting, and then everything else falls into a plug load. At UCF, we break out chilled water production because it's such a big deal for us. It's a very easy thing for us to track and measure. So, and it's somewhere around a third of our consumption. So we look at it very closely. And next, it's evaluate results and then repeat the process. And it's important to remember that this is a never-ending process. This, again, is a review from the last time, but I think it's important to remember what we have control over and what we don't have control over. So these 3 items over here make up what's on our bills. Where rate is set by the Public Service Commission. We're in a regulated utility. We don't have any control over that. We do have control over these 2 middle characters. So we've got control over how big of lights we put into our facilities, how much power we're consuming in real time, and we also have control over what hours we're operating the equipment. And so those 2 make a big difference on your utility bill. We're going to see some of that. This is a pie chart that's presented by the Department of Energy. It encompasses all of the commercial property in the United States, and this shows what percentage the electrical energy goes into the different components. And in Florida, or in Central Florida, our HVAC load's considerably more than this 28%. This is more like 40%. But the reason why I'm presenting this nationwide look is because of the next slide. It talks about the savings that we think are possible with the lighting, and it all relates back to this slide. So out of this 39% that's lighting, through these strategies we're going to look at today, the EPA and the Department of Energy estimate that we can reduce that about 60% without impacting productivity of our workforce. So what do we mean by these strategies? We mean the lamps that we buy, we mean the fixtures, and finally the controls, something as simple as an occupancy sensor or a time clock to something more sophisticated. What we need to remember also is that for every 3 watts that are saved in lighting, 1 watt can be realized in HVAC savings. So they've got another 28% that they're realizing through HVAC load reduction. So the reason why that happens is because these lights aren't producing the heat that has to be removed by the air conditioning system. And then the final sliver here is related to shades in the building. It's either automated shading technologies or manual, whatever. But if those were optimized, the government represents that that's about another 10% savings. And we have not taken that road at UCF at all. We've not investigated that, so I can't really speak to that 10%, whether that's really there or not. Combined, all three of those pies, that represents about 34% of your total electric bill in your facility, in your commercial facility. So that's a significant thing, just approaching the lighting alone. This shows like the cost of what these products that we're talking about. So these 4 bars here represent how much it costs to make a watt of electricity, to produce a watt of power. And the most expensive being solar. This has come down quite a bit in the last year. It's probably about $5 now. Nuclear is constant at $3 and so on. But these lighting technologies that we're looking at are somewhere around 30 cents, something like that, to do these products. So it shows really a huge economic advantage there to working with existing buildings instead of trying to produce your own power or something. This is another interesting slide. This shows the cost of all the things that go into your commercial facility, and it shows how significant salaries and benefits are and how insignificant energy is. Energy is about $2 per year per square foot in a commercial building, where salaries and benefits $318. What I want you to take away from this is not how insignificant this is. Well, first of all, we said that we could reduce it maybe 34%, right? So that would take that down to $1.60, something like that, from $2. Not a lot of savings there, but if we could impact this bar somehow, if through our lighting work we could make even a tiny little 1% change in the productivity, a 1% increase in productivity, we all of a sudden that's another $3. So we've saved 60 cents. So now we're up to almost $4 per square foot per year that we could realize savings. But those are, of course, our soft costs, the salaries and benefits, very hard to measure, that kind of thing. But I think it's still important to remember that, because it could also go the other way on you. If you do the lighting retrofit wrong, you could decrease productivity, and all of a sudden you've not really benefited your organization at all. So I think it's always good to remember that. Some of the trends happening right now in lighting, obviously the efficiency, everybody's in tune with that pretty much. You've constantly got the salesman knocking on the door showing you the latest LEDs that are out there, and they speak to how efficient these devices are, and also the fluorescent technologies and things. But in addition to the efficiency advances, control, there's been a lot going on there. There's wireless technology now in addition to the wired technology we've had for a long time. There's daylight systems, there's occupancy sensors, there's still the time clocks and the astronomical time clocks, and the distributed control versus the centralized control where you have the workstation and things like that to set up scenes and things. There's also sustainability entering the picture. This is all about reducing greenhouse gas emissions, and with the government getting more involved in that, and what the trend is there, whether there's going to be mandates and whether there's going to be taxes and there's going to be such. That's another driving force in the lighting industry. Also, incandescent bans. Has anyone heard about California banning incandescents? It's Australia, yeah. Does anyone also know that the entire country is going to be banned by 2014? Yep. Yeah. So starting in 2012, 100-watt light bulbs are no longer going to be available, just 2 years from now.
Have to make some changes in here.
Yeah, yeah. Gonna have to. They won't have very long though. They'll burn out real quickly. So we have to find a solution for incandescents, and I think the CFLs are going to fill that market very well in the near term. They're starting to lower the amount of mercury in those devices, where they're now manageable and they're below the level where it takes a toxic waste team to clean it up and such. Other factors, security and safety, that's a big one for us at the university. You know, we've got 50-some thousand guests every day that come to visit us, and a bunch of young girls, young men that need to be protected. We need to make sure that they're safe. And so that's a constant a bit of friction at the university between our department and the people that maintain their safety. You know, we always go out there and say we absolutely don't want to put anybody in peril, but we've got to find ways to also reduce outdoor lighting where it makes sense. So the next urbanization, that's the urban sprawl that's, you know, started in the 80s. That's kind of a negative impact on lighting density overall over a community. So it's driven our site lighting loads higher and higher as that takes place, and that goes hand in hand with light pollution, that light encroaching on the natural environment out there. Aging population, Florida's got a lot of this going on where our eyes become less sensitive to light when they get older, and it takes sometimes a greater illumination level. So that's something that we need to be sensitive of when we're working in our buildings, doing retrofits, that we're not lowering the levels where our people are not being productive anymore. And then finally, understanding how the eyes see illumination and light. There's been some realizations there lately through Department of Energy studies where things are changing there. This is entitled Steps Toward Savings, but I want you to think of this more of a system, or more of a systematic approach where I encourage you to really bring all these in simultaneously in a project. And so starting with light levels, we just talked about that, how that there's a lot of factors that determine the proper light level for a space. We're going to talk about that. The next one is the efficiency of the actual luminaire, or the lamp, the bulb in the fixture. Talk about that. And then the fixtures, how well the fixtures are able to deliver the light source out and cover the room without avoiding while avoiding shadows and glare and things like that. Next, we talk about lighting controls and how important I think those are in playing a role in reducing that consumption. And then finally, something that's overlooked a lot of times in lighting is the opportunities for increased maintenance and how maintenance relates to energy savings. Some of the terminology to get us going, and we talk about lamps. Lamps or bulbs. I don't want to confuse that with fixtures. When I talk about a lamp, just the actual luminary itself. And then the lumens is the amount of light power coming out of either a light bulb or a fixture. Foot candles is what is actually hitting the work plane. So in this place, we've got these 36-inch tall desks in here. It's what's measured right at the work surface. Light efficacy is a term that actually talks about to the efficiency of either a lamp or a fixture, and so it's mixing units. It takes the light output and it says how much energy does it take to get to that certain light output, and that's the efficacy. So we're looking to drive that number up as we look for more efficient solutions. Power density is something you're going to see when you get involved in either a major retrofit or a new construction project, where architects like to talk about this, and when they start getting involved in the ASHRAE 90.1 efficiency guidelines, there's minimum standards to get to on that, and commercial buildings are typically below 1 now. I'd like to say they're below 0.9 watts per square foot. I think some of our newest facilities at UCF are between 0.7 and 0.9 that we're able to attain, and when we average the entire building. Driver efficiency, I want to talk a little bit about that, how it's important not to forget about the driver, about the ballast. It's an important player in the whole thing, and it even though you can get a real efficient lamp such as an LED, the driver might, it needs to be considered as a system, in other words, and don't forget about the driver, because it can have a negative effect on the total package. Correlated color temperature, that's this graph over here. This is a temperature scale that's based on the Kelvin range, and 3500 is what's called a neutral ground in this scale, and anything above that number is considered a cool light. Like in this room, we've got kind of a cooler light, not a warm, and these incandescents that are out here are putting out a more warm light, so they're going to be down in this range. So it's an indication of how warm or cool your light is. It's a relative figure based on the